All right, guys, good morning. So we've now spent the last 3 days talking about all the different types of quadratic equations that we can solve by factoring. We looked at regular trinomials. We looked at difference of two squares. We looked at a little bit of five-step method. We looked yesterday at factoring out a greatest common factor. So now we're going to before we move on to word problems, which is going to take us about a week, we're going to kind of step back a little bit. And we're going to revisit linear quadratic systems with our knowledge of now being able to solve them by factoring, right? So we're not going to go through the do now, but if we want to take a look at it, it says solve and check by graphing. So what would we do to solve and check by graphing? We would obviously graph the parabola, we would graph the line, we would look for the point and points of intersection, which is not necessarily the most efficient way of doing it, right? I mean, if on the regions they ask us to do this for, let's say, 4 points, obviously we would do it, we could solve it, we could check it. But as far as if we had to do 3 or 4 of these and we want to think about what's most efficient is generally doing things algebraically. So let's take a look at an example here that we could do algebraically. So how would we do this algebraically? Well, really we're just going to want to use some substitution, right? So if this expression is equal to y, and if this expression is equal to y, then we can basically replace one expression for y, right? What I usually say in class is we set them equal to each other. Right? If the first one is equal to y and the second one is equal to y, then they're equal to each other. So it's probably going to be easiest if we just write x squared minus 7x plus 25 is equal to 5x minus 10. All right, I'm going to move the terms together like we talked about. All right, so now I should get a quadratic equation in standard form. And that's going to give me x squared minus 12x plus 35 equals 0. I'm going to go ahead and factor it, right? So x minus 7 times x minus 5. So we get x minus 7 equals 0. One equation is x minus 5 is 0. All right, so I get x is 5 and x is 7. Now, at this point, if I was doing the lesson in person, my next question would, of course, be, right, why are we not done? And it's the same thing when we solve the regular system of equations. You'd hear me say things like, why are we not done? And then someone would raise their hand and say, well, we didn't find y. So we have to find y for both of them, right? It looks like we should have two solutions, right, two ordered pairs. And we said, with the linear quadratic system, you could have 1, you could have 2, you could have 0. So we would expect two solutions. So we're going to say one of my solutions I can write up here is 7 comma we don't know, and the other one is going to be 5 comma we don't know. So these are going to be my solutions. And how are we going to find out what our solutions are? We're going to substitute. And which equation are we going to substitute? Obviously it doesn't matter, right? So for the most part, it's usually easier for us to sub it into the linear equation, unless the quadratic happens to be really simple. So I have to sub in 7. So if y is equal to 5x minus 10, and if x is equal to 7, I get y equals 35 minus 10, y equals 25. And for my second one now, I'm going to use 5. I'm going to rewrite my equation. I'm going to substitute. And I'm going to evaluate. And I should get 15. All right, so we should have two solutions. Right, and the two solutions are going to be 7 comma 25 and 5 comma 15. And if we check, obviously we did the second one, but if we want to go back and check the first one, when I check 7, 25, when I sub in 7, I get 49 minus 49 is 0, plus 25 is 25. And if I use 5 in the first one, I get 25 minus 35 is negative 10, plus 25 is 15. So they both will check. Again, we can even, if you wanted to prove it, you could check it using your calculator. You could put both equations into your calculator and then either scroll down the table until we see the points of intersection, or you can change your window because the y values are pretty big. You could change your window and you can use the trace and the intersect feature. All right, so just to recap, what do we do here, right? We're going to, assuming both of them are equal to y, we set them equal to each other. We put the equation in standard form by pulling the terms to one side or the other. And then we should be able to solve it by factoring. All right, so we should be able to do the same thing here, right? I see that both of these are equal to y, which means they're really equal to each other. So I'm just going to replace my first one with y. So I get x squared minus 3x plus 10 is equal to 3x plus 1. And again, I can move these together. which is going to give me x squared minus 6x plus 9. All right, so now I have to factor it. So that's x minus 3 times x minus 3. All right, so we realize that what we have here is what we call a perfect square trinomial, meaning the two factors are the same, meaning we're only going to have one solution, one ordered pair. So this is that example that we did look at when we did linear quadratic systems. We looked at one solution, we looked at no solution. So I know I'm going to be able to write a sentence that says the solution is, and I'm going to start with 3 comma something, and I need to find out what the y coordinate is. And again, we can use either equation. It is generally much easier to use the linear equation. And we should get y is 10. So we only have one solution for this one. And again, you can double check that using your calculator if you like, and which should be 310. So if I go back and I check the first one, I get 3 squared is 9, minus 9 is 0, plus 10 is 10. And if I want to go back and check the second one, 3 times 3 is 9, plus 1 is 10. All right, so let's do one more. This one I know you can't see it on the top, kind of as a now try. But I feel like with me, not being there in person, maybe we should model one more of these. And then the next one I'll give you as your now try. So again, right, same procedure. If both of these are equal to y, then I can sub one in for the other. So I guess technically I'm subbing that in. So it gives me 2x squared minus 7x minus 25 equals negative 5x plus 35. So I'm going to add 5x and I'm going to add negative 35 on both sides. So I get 2x squared minus 2x minus 60. Right, and again, let's think about this, guys. I am not going to use the 5-step method unless I absolutely have to, right? 5-step method here is going to break down at the end. Now, fortunately for us, I said when it does with the quadratic equation, you do end up getting the same solutions at the end, but your factoring is still wrong. So you probably would lose a point on the regions. Why don't we just divide out this 2? Right, so that's going to give me x squared minus x minus 30, which we should be able to factor without too much of a problem, x minus 6 times x plus 5. So I split it up here, I get x minus 6 equals 0. I get x plus 5 equals 0. So I get x is 6 and x is negative 5. So I can start by saying the solutions. All right, and I know my x coordinates are 6 and 5. I'm just going to have to find out what my y coordinates are. So again, guys, I'm going to be consistent. I'm going to stick with the second equation since it certainly will be easier. Right, so I'm going to sub in positive 6. So it looks like I get y is 5. So I'm going to sub in negative 5 here as well with negative 5x plus 35. And I should get y is 60. So my solution should be 6 comma 5 and negative 5 comma 60. And if I want to go back to the first one, I get 2 times 6 squared is 72 minus 42 is 30 minus 25 is 5. So that one should check. When I look at the second one, I get 2 times 25 is 50 plus 35 is 85 minus 25 is 60. So that one will check out as well. All right, guys, so this would be your now try then. Okay, so if you're doing what you're supposed to be doing, right, and you actually do want to do the now try rather than just see me model it, you're going to pause it here. All right, so then you unpause it, and then we should be ready to go here. So I've got 3x squared minus 5x minus 25 equals negative 30x plus 25. So I've got 3x squared plus 25x minus 50. So here we actually are going to have to use 5-step method, right? Or we can use trial and error if we want. But I know you guys really love the 5-step method, so I'll stick with that. So this should give me positive 30, negative 5. But remember, since we're using 5-step, we do have to bring back the 3. So I almost actually forgot to do it, but we have to bring back the 3 into both of them. And then we're going to see where there's a GCF that will divide out. Right, so that should be our final factored form. So I'm going to kind of cut to our solutions from there, right? So I'm going to come up here. So if x plus 10 is equal to 0, then one of the roots is x is negative 10. And if 3x minus 5 is equal to 0, then the other root should be x is equal to 5/3. So as far as expressing my solutions, I know that one of them is going to be negative 10 comma blank, and one of them is going to be 5/3 comma blank. So I don't have a lot of space right here, but if I'm just going to kind of sub in negative 10 there, I get negative 30 times negative 10 is 300, plus 25 is 325. And with the second one, I've got negative 30 times 5/3, which should give us negative 50, plus 25 is negative 25. So if we go back and check the first one with negative 10, I should get 300 plus 50 is 350, minus 25 is 325. The second one we're going to get 75 ninths minus 25/3 minus 25, which is going to give us negative 25. So that one we'll check as well. All right, and tomorrow we'll be back with back to quadratics, and we'll be spending better part of 4 to 5 days solving word problems using quadratic equations.